data. We're going to clear out list 3, 4, 5, and 6. If you don't have that data, that's fine. But if you need that data, you forgot to, like you weren't here, or Ms. Fleury forgot to tell you that you should have put it in, you need to go to page 223. Right, it's on page 223, correct? Yeah, page 223, and put sets 1 and 2. I just want to show you again how to clear a list. You highlight your list, you hit clear, and then scroll down. So again, scroll over, highlight the list number, hit clear, scroll down. Okay. Now, the biggest takeaway that I need you to get from this is not how do I put it in my calculator. The biggest takeaway are the steps that we're going to be graphing a residual plot. Graphs are explanatory against our residuals. So we have to find our least squares regression line because you can't do anything without your prediction equation. So who can tell me how to find the prediction equation? I mean, we've already found it, but how do we find it? Okay, so how do we do that in our calculator? Since we have our list, how do we do it? So we're going to go to Stat Calc 8, and my stuff is in list 1 and list 2. So I'm going to tell my calculator to do that. And now there's my information. You guys, R squared, well, I'm just going to throw it out there. We'll take notes on it. But R squared is called the coefficient of determination. It really talks about the variation of the explanatory and the response. We will get to that, but I just thought you should know that the R squared is called the coefficient of determination. So now what we're going to do is we need to write that equation down. So this is a different equation. So, and you guys, this is just a set of data. There's really nothing. And I probably don't need to put all those zeros, but because it's me and I get on to you. So that's our prediction equation. That's our least squares regression line. Now remember, our correlation isn't great. So our prediction line probably isn't going to be that good predicting. So it's okay. So what we're going to do is to make a residual plot, we have to find the predicted value, right? So we have to take all of those numbers and put them in the equation. Well, to put all of those numbers into our equation would take time. So what we're going to do is we're going to tell the calculator to do it. So we're going to go to stat, and we're going to go to stat over to list 3. Okay? And we're going to highlight list 3. So we're in our calculator, we're in our list, and what we're going to do is we're going to tell our calculator what to do. You guys, if it says make a residual plot, the first thing you need to do is you have to get all of your prediction values. And to get your prediction values, you need your least squares regression line. So we're going to say 3 plus 0.5 times second 1. So basically what I've done is I've told my calculator, can you please find the prediction for me? Because I don't want to do it manually. To do it manually, you guys, you would actually do 3 plus 0.5 times 10. 3 plus 0.5 times 8. You would have to do it by hand. But what we've just done is told the calculator to do it. So that's the first step. So if you're making notes, the first thing you do is you have to find the predicted values. So there's all my predicted values.
Remember, you got a good syntax.
Okay, so I found the residual. I found the predicted. What is the residual?
Is the actual minus predicted?
Yes, it's the actual minus predicted. So you guys, this is everything we would have to do. So we would have to find our prediction values. Then we would have to find our residuals. And our residuals are our actual minus our predicted. Well, our actual or our observed are in 3.2. I'm sorry, list 2. our predicted that we just came up with, our list 3. This is something we can do by hand, but because we have so many numbers, we're doing it in the calculator. So to do that, we would do actual, which is list 2, so L2, second 2, minus second 3. So I don't want you to get wrapped up in, oh my gosh, it was list 2 minus list 3. What I want you to get wrapped up in is I'm finding the residual, which is the actual minus the predicted. So highlight your list 4 and do list 2 minus list 3. So now that list 4 has become our residuals. So when we think about our residual plot, okay, our residual plot is going to be like this. And then we're going to, you guys, I mean, this would be 0. I mean, no, these would be our negatives. And this is how I always think about it. This is our 0. I guess you don't need that line there. But this is our explanatory variables. And you guys still can't see that? There we go. Those are our explanatory variables. And this right here are our residuals. And I will move out of the way, I promise. Okay? So what we're going to do is if we were to graph this by hand, you guys, of course, a piece of graph paper would be the best. But if you were to graph this, this is what your graph is doing, okay? Sometimes when I first learned it, by the person who taught me, she would go into your y equals, like your equations, and put the actual line in so you could see it. So now what we're going to do is we're going to do a scatter plot. So we're going to go into second y equals. We are making a residual plot. A residual plot graphs the explanatory variable, our x values, against our residuals. So, which is our observed minus our predicted. So in our case, our actual was in list 1. Well, in my calculator, my actual was in list 1. And my residuals were in list 4. And then you can hit zoom 9. And that's a residual plot. So it's just like a normal scatter plot. You would go over your explanatory and then your residual. So again, so when you go to graph it, remember it's your explanatory and your residual. How do you find that? You have to find the predicted value. Then you have to find the observed minus the predicted. So there's a lot of little moving parts. So I don't want you to get too caught up in the, like, oh, what was I supposed to put in list 3? What was I supposed to put in list 4? What you need to think about is, okay, I need my least squares regression line, I need my prediction value, and then I need to find my residual. Now, this residual plot, look at, you guys, look at that point right there. That's a good residual because it's almost 0, right? You want your residuals to be as close to 0 as possible because the closer your residuals are to 0, the better your least squares regression line is predicting. Okay? There's a couple high ones, right? This one's probably not that good. This one up there. So a residual, this is not a bad residual plot either. They're far away from each other. Like, I'm not far away. I should say they're not as close to that 0 line that you would want to have. So you want them closer to this line. They're kind of spread out. So you know that it's probably not a great prediction line, in which we knew because when we looked at our correlation, it was only moderately strong. Can you still use it? Yes. Is it going to be as accurate as one with residuals close to 0? Probably not.